interested and amazed at whatever it is you have on your screen here. It looks really cool. I love copper coils. I've got a few examples myself as well. We got a different screen share here. You have a photo.
Share some pictures first.
Okay.
Okay, what I'm about 4 or 5 months ago, I was watching a Carrie Ellis YouTube interview with Jackie down in the States, and she's the gal down there that's also experimenting with carbon magravs. But she's also one of these people who's are sensitive to the fields, and she actually uses dowsing rods to determine how far out the field is from, say, from her car maggrav units. So with ordinary tap water, making her Gans from ordinary tap water, you know, the salt water in the Gans, her maggrav fields on the car units were out about 20 feet. Okay, that's with the dowsing rods detecting them. And then they energized their tap water by putting, this is a hard one to see. I needed more light on this, but what I've done is I've taken a 1/4-inch plastic tube, filled it with zinc and carbon dioxide Gans with just a milliliter of H3 and a milliliter of H2 in there. That's why it's they got this brownish color. And I just wrapped that 25-foot length of plastic tubing around my water pipe coming into the house. So that's about a 2-foot length before it turns here sideways, goes to the meter that I got this wrapped around. And just a little closer look, and then that's the end there. And the ends of these tubes, I just got them, you know, taped on, and they're just plugged with hot melt glue. Now, before I put this on the water pipe, the Okotoks city water here has a pH of 7.3, and after I put this on, the pH of my water is 7.6. So I went up 0.3 on my pH just with this simple little.
You did a number of tests on your water initially to make sure it was at that level and so on. Is that part of the process? Or?
Yeah, it was about 7.3 about a month ago,
yeah.
And then tonight before I put this on, I just put this on tonight. I calibrated my pH meter and tested it again, and it was 7.3.
Oh wow. So, yeah.
And then
right after you did this, no preparation or no setting time or anything. You just right after you put it together, you did another test. Is that the way it went?
Yep. So after I took that pH test, I went downstairs and wrapped this around the pipe, and then just before the meeting here, I came back up and ran the water for a while and got 7.6.
Wow, that's pretty incredible.
Okay, so this is step 1 of the process. Step 2 is to actually run your water through some copper pipes and in a bucket of Gans. Okay, so this was my copper pipes. You gonna pin me back on there, Rick? Okay, so I got a 3/4 inch diameter water line coming into the house, and I thought these were 1/2 inch, and 2 1/2 inches would have given me 3/4 equivalent volume of 3/4 inch, but I misread when I bought this. It said 1/2 inch on the copper, but it was actually 1/2 inch outside diameter, so it's 3/8. So I got to do 2 all in parallel so that I can get my volume of water back into the house. So the idea is, those are my copper coils. To bend these, what you do is you fill the tubing with water and put it in a freezer and let it freeze, and then you can bend the pipe This inside one was bent around a 4-inch ABS pipe, and then the outside one was bent around a 6-inch piece of chimney pipe.
Ah, that's a great idea with the water. I've done it before with sand, but that's a lot more hassle.
Yeah,
good idea.
Sand works the pipe, but when you got this is 50-foot long pipe, it's hard to get all the sand in there. So
that's right.
So the idea is this is going to go in the bucket. These copper pipes and the inside of the bucket, everything are going to get nano coated. And right now I got a problem. I got to adjust something to get that to fit in the thing, and then there'll be a manifold up here, and it'll tie, go into one side and out the other back to my house line. Should get Energize. But as I say, now I got to get a second one, so I'll have two of these buckets in side by side to get the volume of water that I need, so I'm not slowing the water down going into the house.
I see. And now, how do the pipes go again? You've got, what, 4 pipes coming out of there from the 2 coils? And how is it connected underneath and so on? Does it all go through?
It's just a riser going up. So basically the water's going to go, say the outside coil, the water's going to go in and up and out back to the house, and then on the other coil it goes in around and back to the house. They're in parallel. It's just that one's inside the other to fit in the bucket.
Just for the bucket, they're not connected to each other, so it goes through one and then the other one. I see.
I think the training we had a year ago showed us that with a coil that was in one great big long line up, one long line, okay? So I was just trying to make them to go into a bucket.
It may have some effect between the 2 coils. I mean, you have a coil inside of a coil. It is an electrical configuration, a plasmatic configuration. So perhaps the plasma flowing through will have a amplifying effect of some sort. It's possible. But I see what you're doing. You're doing it for flow, so you've doubled the flow in one bucket and double it in the other one, so you're trying to get back to your original flow in your house through all that.
That's right. So I get 3/4-inch pipes worth of water flowing through.
Right.
Now, going through in a spiral here in the coil, we're getting into, I don't know if there's a scientist called Schomburger who...
Schomburger, yeah.
Schomburger, okay, and that energizes the water too, just getting the water to flow in a coil. So that's a good thing. And I'm thinking here now, if I put my Ganses right, I should be able to get an infinity loop between these 2 buckets. And maybe even if I put a ball in the center of this coil, I can get an infinity loop between the Ganses in the bucket, and an infinity between the buckets, and another infinity between the ball and the Gans in here. So I should be able to get something good going.
Yeah, maybe you can generate power by putting a coil on your water pipes and just draw off the power anywhere in the house where the water pipes are.
Anyway, it's going to be interesting how energetic my water is.
Yeah,
so anyway,
that's great.
After Jackie did this in her house, and then they made the Gans out of this, the energized water, or they made the salt water when they were making Gans out of the energized water. The field on her car mag-grav went out to 200 feet, from 20 feet to 200 feet. Okay? And then she started reusing the salt water, like she'd make a batch of Gans, she'd save the salt water and use it for the next batch of Gans, save the salt water, use it for the next batch of Gans. So she sort of tripled her uses of salt water. And she says they drove their car away from the car mag-grav, and it was 5 miles out when they detected the end of the fields. So
are you saying things were changed in the car mag-grav, or just in the environment changed the car mag-grav?
The Gans they made that they dipped their coils in for the car mag-grav was more energetic.
Okay. I get it.
Okay, and was putting out a bigger field. So number one, if you start with energized water, you can get quite a larger, more energetic Gans and get more energy out of it. And number two, if you start reusing your salt water from, one Gans production to the next, basically save your salt water and reuse it, you can, again, increase the energy of your Ganses. So that's my goal, is to get higher power Ganses, because maybe that'll be one of the secrets to getting my carbon magraphs to work better. So.
Interesting. Okay. So you're going to do, excuse me, you're going to do some more tests on the pH and so on this, I presume.
Yep.
Once
Oh
it's
yeah,
hooked up.
after I get this hooked up,
Yeah.
we'll be testing the pH. That's the only indication I've got to of whether it's changed the water in any way. I don't have dosing rods or any any pendulums or anything like that to.
You could, well, you might
Tag
note
fields.
a difference in the taste in the water or some other, texture kind of thing. It might tend to soften the water more or something like that. I don't know. It is running
Yeah.
through a lot more copper, that's for sure. And you'll have to flush it. You got solder joints on there with regular solder and so on as well. Is that the way they're
Yeah, this is all
connected?
solder joints. It's got
Yeah.
test
So,
caps on there, so they don't get any caustic down in the pipe and
right, yeah, I was going to say,
and all that.
need
So.
to flush the pipes a bit first, because I would think that the solder should actually decrease the pH, if anything. So that's what makes it even more interesting, is that you found an increase in the pH, and that means it's more, toward the basic side and not
Yep.
acidic. And you'd think it would be more acidic if you have all those solder joints and added into it, at least
Well, he hasn't used the solder yet, Rick. He used the plastic
Yeah, I haven't.
tube.
Yeah, I
Oh,
haven't done
okay.
this.
Okay, good point. Well, we'll
But
see. If it does increase the pH, then it'll be even more of a minor miracle with the solder in there, because it'd probably take a bit to flush out the acid part of the solder, I would think.
yeah, I don't know. I mean, we used to use copper pipes in houses all the time, and we just solder them together and turn the water on. We never really flushed them out. So.
Yeah.
Well, I don't know if you'd want to use plastic tubes, but that's an option. If you're concerned about the solder.
Other than the pressure issue, you'd have to make sure it was able to take the 70 pounds pressure or something like that.
Yeah, some of those tubes for those purposes get kind of expensive.
Yeah.
Yeah. It's just copper is easier than nanocoat, and then you see it black, you're sure it's going to nanocoat it. Plastic, well, we put it in caustic and so on, but we never know whether it really is nanocoated.
Yeah, it probably comes nanocoated because it's gone through a heating process.
And you're not going to be nanocoating the inside of the pipes. You're just doing the outside, correct?
Just the outside.
Yeah.
So it's just where the Gans is in contact with the pipes, so they're in contact with the nanocoated layer.
The Gans solution, you're going to use again is?
Well, I'm still thinking on that, because I was just thinking, thinking about the infinity loop connection on these two buckets and the possibility of putting another ball inside here with Gans in there. But it's mostly going to be copper or not copper, CO2 and zinc. But I might put just a few drops or just a little bit of H3 and H2 in it, just to vary the strength or something in certain. Like if I put I wanted a strong ball in the center here, maybe I'd put some H3 in there or something, and then go to the copper zinc, not copper zinc, the CO2 and zinc. I'd have a weaker CO2 and zinc in the next bucket, so I got a connection there, and then probably go, I don't know whether to go weaker again in that next ball or whether to go stronger,
Okay, when you're looking at this, Lee,
Yep.
think about the secondary benefits you're going to get from it. You're after a better car unit, but look at the secondary benefits, the health benefits.
Oh,
If
yeah.
you're using that water. So when you design the Gans, think of that as well and see how you can, I don't know how you're going to calibrate it, but see if there's a way that you can check the influences of what's going on. Back in the day, I had a particular unit that we used, and there was a lot of health benefits just from drinking the water that never touched the unit that we used. So always check who else is drinking the water and seeing what's going on with them. Do you have animals as well? Check with, do you have animals?
No, I don't have any pets.
You don't have any cows or horses or sheep?
Nope.
Okay, well, I guess you just watch for the mice.
They keel over, you might not want to continue with it. But if they're happy and multiply, then that's a good thing. The more mice you see, and especially if they're happy, then that's a good indicator that your system's working.
Another thing I'll suggest is if you're going to fight with that copper and it doesn't quite fit in a bucket, get a taller bucket.
Well, it fit in the bucket before I soldered all the joints up. So I actually got one of the riser pipes soldered to it got stuck to the outside of the coil, and I got to heat it up and break that connection so that I can uncoil it a bit at the bottom to get that inner coil down.
Well, it's a neat idea. I'm also thinking like it'd be great to do some sort of test on water quality. You know, like what if you had some, I was going to say polluted water, but you don't really want to put polluted water through your system unless you're using it specifically as a test system to see if it can decontaminate the water. Because it possibly, you know, going through, especially I like the double bucket method. It seems like you could treat it one way in one bucket and another way in another bucket and perhaps decontaminate the water. I mean, we know that the copper oxide, the black coating, the nano layers on copper is an excellent germicide and decontaminant. Copper itself is known by the FDA. It's been declared as a what do you call it?
It's a fungicide, a bacterial side.
Yeah, bacterial side. Yeah, it's the first material, first element, first material that they've declared as having those qualities that basically kills germs, and just bare copper by itself, and then the copper with the nano layers on it is also known for taking out heavy metals. You could have heavy metals in your bucket water, and that nano coating will literally take out the lead, other heavy metals similar to lead, even radioactive stuff will actually be drawn right out of the water by that black coating in a matter of they have estimates of roughly 98% of the lead will be taken out in the first hour to 2 hours, and literally virtually 100% within a day or two of contact. So it's an amazing substance that way. You're using it kind of inside out, but I'm thinking that the fields of that nano layering are going to work on the inside as well and be changing what's inside there and basically neutralizing that which is not not supposed to be there in terms of those fields. But the thing about it is, normally the black coating would actually absorb and take into its structure that heavy metal stuff and take it out of solution. So in this case, I don't know what it would do really. I don't think it would coat the inside of the pipe, but maybe it would convert it into something less noxious. But it'd be great to do some sort of test that way. What does it do with bacteria? What does it do with heavy metals? What does it do with the pH and so on?
Yeah, maybe I need a third bucket down below here, like CH3 in it, so the fields drain the, the lowest energy Gans, and that'll be the sink for, any of these heavy metal fields to accumulate in or something.
So I'm going to jump in here just for a moment, Lee, just to add some color. Jaleel, in the testimony on Monday, I guess it was Monday, I can't remember, Tuesday.
Monday, yep.
Monday, he had a nice system for a health system. And so today I began designing a health system designed like a MagGrav unit. And one of us using 3 buckets with plastic, with the water being pumped through the tubes of the MagGrav. I mean, the liquid plasma being pumped through the tubes of the MagGrav with a Tesla pump like Rick showed us a little while back. And I was using three containers, and I was using them as health units, where you stood in the middle of the three containers, and the plastic tubes were built like a MagGrav coil system, and you pump the liquid plasmas through the tubes. And I was going to show that a little bit tonight, but I don't have to. This is great. Thank you very much. Keep going.
Well, that's all I got, unless there's any questions or suggestions.
Yes, I would make only one suggestion, is that when you use a third bucket, if you can find the means to use a plastic tube, and maybe even run plastic tubes around the pipe like you have done downstairs, and you think a little bit about some different varieties that you might want to use because of the secondary benefits. Of course, your primary thing is to get the fields on your car unit to be more effective. So you do have your primary, but you may also have a secondary. So that's the only suggestions that I have.
Yeah, I mean, like it's not just my car units. I'm trying to make more powerful Ganses, all my Ganses from now on, to have more energy, basically. And the car unit's just one example of where they could be used. So.
Well, excuse me, Rick. I'm just going to jump in. You can, just have a faucet that instead of the whole system, that could run through a system by itself as well, a system specifically for that. It doesn't have to go through the whole house.
Well, I think there's going to be some health benefits out of this too.
Yeah. Well, excuse me, Rick. Go ahead.
Yeah, I think it's great. Imagine taking a shower with the water that comes through that system. It's especially like you mentioned, the 0.3 difference basically, and basically is the word too. in the solution being more basic by 0.3 pH, which is actually quite a bit when you think about, you know, the volume of water that goes through, and that it's simply going through this very simple system with no external contact. I mean, sure, you could see if it was a water softening system or something that added acids or bases to, it's usually a basic solution or a salt solution that they add in order to soften the water and change the pH and that kind of thing. But that's when it goes through special filters with that has you know, chemicals in it and that kind of thing, where it's in actual contact with the water. In this case, we're talking about what can only be field interaction, because there is no direct contact between the, you know, contents of the bucket and the contents of inside the pipe. So therefore, it's a plasmatic environment, a plasmatic magnetic gravitational environment that's important here, and that's what's great about this as a demonstration. It's if it does provide that effect, that's significant. If everybody in the world had their water, which is generally speaking too acidic, suddenly be, you know, 0.3 pH better, that would be a remarkable accomplishment.
That would be a huge health benefit for everybody in the world.
Yeah, yeah.
When you look at these things too, let's say you had it set up in a maggraph type form, you'd be able to check the different voltage and amperage that water generates within the coils themselves. When you start to look at some of these overall effects, you might be wanting to test the flow of electricity through these coils.
In fact, that might be an actual sensor for the amount of contaminants or impurities in the water. The voltage might be a direct reading of the amount of, well, let's say the particulates. I mean, think of what do they call it, ppm meter, parts per million, or what is it, particulate density meter, or whatever they use for our solids. What is it called? Particulate solids meter that they use for measuring fertilizers and measuring whether there's particles, your salt solution, and so on. I've got one somewhere actually. But parts per million of particulates basically is an electrical phenomenon. Maybe it would register that in some way. You could actually have a little meter on the side that was reading off the copper pipes, telling you what's inside, in effect.
Actually, what you'd probably need a settling tank in the system, like in the hot water system. Maybe if the water gets energized, these particulates might settle out to the bottom of the hot water tank or something, and maybe you could, if you had some kind of a settling tank in the cold water line too, maybe it would. Something to look at, something to test, maybe. But yeah.
Mm-hmm. Well, that's true, and the hot water tanks have that tap on the bottom that's made for flushing and cleaning and so on. It's actually a fairly easy way. You could do it beforehand, test of the stuff that comes out, and then after running for a couple of weeks or a couple of months or whatever time period, you know, you should actually do samples on a daily basis and see if it changes the contents of that particulate that forms in the bottom of the hot water tank.
Anyway, it's a lot more testing than I can do.
Well, we're suggesting things for others, to give others the opportunity, right, Lee?
Yep.
So,
we're the innovators, and others can do the grunt work of the actual lab data, because actually it should be done in a lab in a university and the results published, so we can, you know, actually establish some credentials on this kind of thing. It's a great idea. I like it. Okay, any more questions for Lee here? Or suggestions?